Good morning, everyone. How are you? Right? It's a bit early, isn't it? So good morning. I'm going to try to say this as well. Günaydın Istanbul. I'm not very good at the accent, but instead of this, I can speak about the two things that I like a lot in Istanbul, chai and baklava. So you can skip good morning to me, but if you give me chai and baklava, I will be happy for the rest of the day. So that's great. So you discussed a bit between yourselves about today, and you introduced yourselves. Does anybody want to share why you are here, what you expect to learn? Just one person. Anybody brave? No brave people today. Anybody? Okay. So we'll try to talk today about something that goes beyond our usual development practices. We'll try to move forward beyond programming languages and beyond usual things. First, a few words about me. I'm Alex. I'm a polyglot programmer, trainer, and coach at Mozaic, which is a small company with heart, living in Bucharest. We did a lot of cool things, and maybe you recognize some of these. Hopefully, if you've been to a code retreat, we are part of the history. If you heard about programming games like brutal refactoring and taking baby steps, again, they came from our team. And my official role is CTO, but this is what I usually do. So if you notice, I also do teddy bear pair programming. We have those teddy bears that we give out to developers. So whenever you are alone, you have a difficult problem, you don't know who to ask, you have your teddy who can help you. So it's really great. And I'm working on a product that's called Eventrix.co. It's a startup. The only reason I'm mentioning it is because I will be talking about some of the things we do behind the scenes in this talk. And it's a product used by event organizers and speakers to organize events like this one. But before we start, I think I have a belief. My belief is that you as developers deserve better. We've done a lot of good things in this industry. We learned how to do things better. We came up with agile software development, with lean software development, with software craftsmanship. And these are really good things when applied correctly. And they make us feel a bit better, but we still have problems. We still have issues like this. And I hope you haven't encountered this. But I do remember 10 years ago when I was doing programming in C++, I hunted a bug for 6 months because it was an intermittent bug because of a type that was too small and overflown, but only in some special cases. So it was a really tough one. Or this one, although hopefully you don't have compilation problems now, but maybe what you do is you fix a bug and then you get 20 other bugs back. I see people laughing, so I think you know what I mean. So sometimes you don't know why things are working and you are too afraid to work on this. So this took me to another thing, which is, this is not a quote from an actual programmer, it's from an actress, but it still applies some days to developers, because we all know that this is the only valid measurement for code quality, right? So this reminded me of something else. I like to read a lot about design in general. I like to read about design as other disciplines do it, about industrial design, about user interface design, and so on. And I read at some point about this guy, Jacques Adelman. Jacques Adelman is an artist, a designer from the 1960s who created a catalog of impossible things. And it's really to show how design can go wrong. And if you look at, he's wearing one of these impossible things. He has lenses, but one of them is a watch, and you cannot actually see through it. And he came up with some other ideas, like a coffee pot for masochists. Very, very good. Or absorbent bottle. It's a 1 liter bottle, but it can hold 2 liters. Unfortunately, you cannot transport it anywhere. So there's that. Or this one, which is very, very useful, of course. You can. But the thing is, I read about Jacques Adelman in a book, and the book was about, it's called The Design of Everyday Things, and it started a revolution of user experience and usability. And one quote from the book resonates with me a lot. Donald Norman, who wrote it, said, "It is the duty of machines and those who design them to understand people. It is not our duty to understand the arbitrary, meaningless dictates of machines." And I resonate with this because I often, when I work with software, I realize that, okay, I don't understand what is going on. So this book started the revolution of user experience and usability. So now, I was reading about these things, and at some point in Socrates UK conference, they kind of connected when we had a conversation about what is good design, and one of the things that came up was who is the user of software design. It's very easy to say that when we think about users of objects around us, like a chair, somebody designed the chair for somebody else, and it's clear for whom. It's for everybody who's sitting now, right? But when you think about software, we often tend to say that the user of software design is the end user. But that's not true, because I use WordPress. I hate every line of code in WordPress, but I use it because it works. I don't care how it's structured. It works somehow. I don't know how they do it, but it does. So it's perfect. So it has to be somebody else. The end users don't care how your code is structured. They only care if it does the right things. So the only people who care about how code is structured are the developer. And because we have this idea, the next question is, once we know the user, we have another type of design, software design, we know the user, can we improve this using techniques from user experience? And I started going on this path and trying to learn more about how these things are, can connect. So I came up with a few things, and these are some practices that are done by usability UX designers, okay, or usability designers, personas, user journeys, quality attributes, usability testing, and some specific practices. So let's look at each of these. For personas, what are personas? Personas are, we build now also an application for doctors. And if you think about doctors, there's a whole range of people, right? There are young students who know everything about internet, use mobile devices and so on. And you have old people, 70s, who type like this and don't see very well, need glasses. So how do you optimize your design for both of them? You have to think about each of them and to define their needs. And it's the same for developers. These are a few personas that I came up with, but I'm sure you can come up with more. But you can already see it's much more different to think about kernel development than it is to think about JavaScript, CSS, front-end development. It's a whole different world. They work differently. So these people have different needs, and saying that everybody should use the same types of design, the same rules for design, is probably wrong. There are certain rules that apply everywhere, but there are then a few that don't. So usability depends on the user, and this is the most important mindset switch that has occurred when we started building applications that you can actually use. The reason you use mobile phones today so easily is because these people have, like Donald Norman and so on, have established a practice of UX and have changed the mindset towards thinking, starting from the user and not starting from the engineering point of view. So it's the same thing that we need to do here. Now, when I told this to my friend Johan Martinsson, he did something very interesting. He went into his team, one of his teams, and started a conversation about what does this mean to us? What do we want? What is our kind of persona? What are the rules that we want to follow? And they came up with a set of 5 rules. I'm not going to go into all of them, but the important thing here is that it wasn't something imposed. Until then, he tried to come up with things like, let's use solid principles, let's use clean code, let's do code reviews, and so on. And the very good question that we rarely have an answer for is why? Why do we need that? It's some extra work. And why do we need to do these things? And by having this conversation, the team came up with the rules they wanted to follow. And if you look at them, the next consequence is that they go into practices. So each of these rules tells us a few practices, and we find the why behind the practices, which is very important. So now it was much easier to have a conversation about clean code, about code reviews, about unit testing, and things like that, because everybody understood it's useful for all of us. It's not me writing tests so that you don't have to fix a bug. It's also the other way around, because we work in a team. So this is about personas. The next thing is user journeys. This practice for usability engineers, for UX designers, means figuring out what are the steps a user needs to do very commonly in your product. And if you think about developers, what do we need to do? Typically changing code. And this is the kind of user journey that I found for this. And we can go into more details for every one of them, but we won't have time. So I'll just talk about a few things that apply here. So if you look only on the first step, the first thing you need to do is to figure out what you need to change. So imagine you get a task. You need to implement something in your code base. And when you implement it, first thing you need to figure out is, okay, what do I change and where? How easy it is for you to do that? And that's the mindset of UX designers. We start from this flow and try to optimize it. And actually figuring out what to change is really a matter of, if you don't start the application, if you just look at the code structure, can you tell where to go inside the application to change something specifically? So inferring runtime behavior from the static structure. And what is the first thing you see in IntelliJ, for example? You see namespaces, typically, packages. How are those packages typically? Models, views, controllers. They tell you nothing about what you need to change. You may know that if there's something related to UI, you need to go into the views, but what view? And where is it located? So there's another way, which is advocated by people like Simon Brown and Sandro Mancuso, which is organizing your namespace based on what they are doing instead of the technicalities of it. So instead of having namespaces and packages like controllers, models, and views, you would have namespaces that are organized by feature. And if you look at this, and I tell you, please go and change something about the invoice generation, you'll know to open the first thing. You'll know to go there. And it's very easy to find it. Another example are modules. We have, again, if modules are correctly named, and if you have your application split into modules, even if it's a monolith, okay, it's very easy to find where to go to change something, as long as every module has a clear responsibility. Now I left one here on purpose, which doesn't have a good name, and is the first one, which is actually a CRM client. It's not CRM. CRM is not a very good name. But it shows already that if you want to change something in the way the currency is converted, you go here. If you want to change something in HTTP client or something like that, add some authentication or things, or HTTPS, you know exactly where to go. So again, it's a way of structuring your code that allows you to go faster to the place where you need to change. And this brings the next question, which is your design easy to navigate? Because once you figure out kind of the rough structure of the code, then what is the exact file that you need to change? Or how do you get to it? And I think navigation is one of the most overlooked problems today. I've worked with companies that use Visual Studio basically as Notepad because they had custom build systems. They didn't have solutions, and they couldn't find the right files very easy. So every time they needed to change a file, they would start an index program, search for a file, open it, change, look at it, and then see they need to change it to another file, go to the index again, search again, and do this over and over again. And then, obviously, after 15 minutes of doing that, you have a meeting, and you forget everything you've done until then. And when you come back from the meeting, you start it all over again. And it was really, really slow and painful. So, navigation is a very overlooked problem, although we have today IntelliJ and IDEs that are powerful like this, where you just type a combination, a keyboard combination, and then search for a string, and then you'll see all the classes that you use that string in the name. So if you just optimize a bit for your ID, you'll be able to get to the right thing, as long as you do a few more things. So first, you have to figure out module namespace, but then the naming needs to be consistent, memorable, and precise. If sometimes you call your invoice-related object invoice, with invoicing name, like invoice controller, invoice view, invoice whatever, and other times you call them, I don't know, factor view, factor controller, factor something, it will be very hard to figure out which is the right one. Even though these are synonyms, but it's harder to find them. And then the name should be memorable, because if they are not memorable, you cannot remember where to go. And the third thing is precision. If the name doesn't tell you exactly what the class is doing, it will be very hard to find it. Also, if you use dependency injection, you typically will find easy to navigate to the interface, but then if you have like 10 layers of inheritance, which class do you go to? So there are things like this that, if you optimize for navigation, will push you in a direction of design that's quite interesting. And if you think about navigation, it's something that you do maybe hundreds of times a day, going to files, changing them, go to another file, change it, and so on. So just optimizing 10% out of it will give you more time. And here's an example of consistency. I was talking about names. If you look here, you have a clear, not only you have a clear package structure that tells you what it's doing, but you also have kind of controller request view, you know what to look for. If you want to look for all the requests, you type request. If you want to look for everything related to invoice preview, you type that, and so on. It's very easy to find the things you are looking for. Now, I do realize that you are working in more complex applications, and it will be more difficult to do that. But the thing is not to try to get to the ideal thing immediately. It's just making small changes so that if you gain even 10% efficiency, it's already a good thing. I was talking about module. It used to be that module had a very clear API. We used to have, in C, you just wrote a .h file with all the functions you can call, and those were the only functions you could call. You had no idea what lies beneath them. In Java, we tend to do things public, or especially if modules are inside packages like this, you kind of can access them. So because of that, you need a way of defining an API. And one way that I've used was facade pattern. So whenever you have a module, I also define an API for it, which is a facade. And everybody calls the module through this. Now, if you are doing things like microservices or things like that, there's already some higher degree of separation. How does it help? Well, it helps you to navigate to the right module. It helps you to understand what is called and how. Okay, but this is only the beginning, because the next step is to define usable software design. And what I'm saying is usable software design is any code structure that exhibits design qualities that are similar to usability. Now, what are design qualities of usability? It's a heated discussion in the UX community, but they came up with a definition that everybody can be unhappy, equally unhappy with, and this is the one that's here. So when we talk about usability, we talk about things like learnability. So let's say you're using a mobile application for the first time. How easy it is for you to start using it? Do you need to read a 100-page manual to start using it? Not anymore, because we do usability. And this is learnability. It's how fast you can use an application from the moment you start using it. Then it's efficiency. Once you learn that, how quickly can you do your typical tasks in the application? The third is memorability. So let's say you don't use the application for 6 months and then come back. How fast can you still, can you relearn to use it? The fourth one is about errors. So let's say you do something in the product and it generates an error, how easy it is to recover. And the fifth one is satisfaction. How do I feel when using that application? Now, if we go to software design and think about developers as users of software design, then the question is, for learnability, imagine you get a new team member. They don't know anything about your code base, they have no idea where it is, how fast does it take for them to become productive? Because if it takes 2 months, it's a bit of a problem. If it takes 2 weeks, it's still not that good. If it takes 2 days, I guess it's okay. So that's what we are talking about. So if you plan to hire, let's say, 20, 30, 50 more developers, or if your company is planning this, the investment in learning can be quite high. It doesn't matter if you only hire 1, 2 developers. Okay, it's not that a big a deal. But if you want to hire more, then it's a problem. So then, what can you do about this? We discussed about things like code structure, consistency, and so on. But I have a story here, which is, I did a usability test with Johan Martinson, and he showed me a Node.js class. He's working on a Node.js project. I don't know a lot about Node.js. I just can read the code, basically. And the point of this test was for me to figure out as quickly as possible, without any help, what that class is doing. It took me about 15 minutes, and we found some design problems in the process, but the most interesting thing was that for some reason they had tests, but I couldn't navigate to the tests. And I really needed some usage examples. And I couldn't find the usage examples very quickly. So it really turns out that it's really helpful for us to have usage examples for a class. Now this was a very specific class. It was kind of a data processing pipeline, and it was somewhere in the middle. So it got some kind of data structure, got out some other kind of data structure, and I had no idea why it was doing that. And again, I had no context at all. So in this situation especially, it's very useful to have usage examples. So I did a change request to JetBrains about this, because it would be really cool if they could kind of parse your tests and then show usage examples, like press a key combination on a method and see the usage examples for that method. That would be really, really cool. It doesn't have a lot of votes, so if you want it, you can vote it up. Okay, so how do we measure learnability? How do we optimize for it? That's the best way. Find somebody around your project, not necessarily in your team, who doesn't know what you're doing, kind of knows the technology. Show them a class from your system and see how long it takes them to understand what's going on there. And see what feedback you get. Because then you'll figure out why it's so hard to learn or to use the existing code. The second one is efficiency. So once we've learned the design, how quickly can we perform the tasks? And there are a few ways of optimizing this. There's fast validation, which is very useful. In this case, things like unit tests, they speed up development a lot because you stop thinking about what may go wrong. The tests will tell you. So you go faster. But one that was kind of strange, and I discovered it in the process, was using code constructs that all the team can understand. So now we have lambdas in all programming languages, but about 7 years ago, Microsoft launched delegates in C#, and you could abuse delegates and use them as lambdas. Now the problem is, it was a very useful thing back then, but when I tried to use it, I noticed that nobody else could understand my code. And so I had two options: either teach them, which I wasn't ready to do at that point, or not use it. Those are the two good options. The third option was kind of use them stealthily and forget that they don't understand, because who cares? But I didn't want to do that. So I stopped using those code constructs. And if you see people struggling with certain ways that your application is built, I can think about promises or things like that, it's probably better to train them or to find a way, or to avoid using them, kind of wrap them up somehow. But otherwise you will lose a lot on efficiency, because you'll get bugs, and then somebody needs to fix the bugs, and so on. Now, how do you test efficiency? I have a favorite question for retrospective, which is, what slowed you down in the past 2 weeks? And if you have a good open culture where people can share and can say openly what was wrong, what slowed them down. And they don't feel that it's their ego, you know, that somebody will punish them for that. If you have this culture, then people will tell you. And then you can improve look at those parts in the design and try to improve them if this problem is consistent. Another thing that we do is because we use a Kanban system, we measure the cycle time. And so we can very quickly say, if usually we get like 2 days for a story, if some stories go to 6, 7 days, something was wrong there. So how can we improve the design so that it's faster when we get a similar story again? And of course, it's more complicated than that because sometimes it's a one-time thing. So you only do it once, it takes longer, okay, you don't care about optimizing it. Sometimes it's a thing that you will keep doing and you know you'll keep doing, and then it's worth optimizing for it. Now about memorability, when you go back to the design, let's say you leave for holiday for 3 months and then you come back into the project, how easy it is to start being productive again. And I want to talk a lot about it because it turns out it's kind of efficiency plus learnability. So I will skip that. Now about errors. When you have an error in a mobile application, the ideal thing is to tell you how to fix it and to give you hints about what you did wrong and how to recover from it. Now we have errors and mistakes in software development, only we chose to name them bugs, right? But bugs don't just appear out of nowhere. Somebody makes mistakes. A developer who didn't understand things, or somebody who didn't clarify a requirement. And the most important thing when you think about mistakes is it's very easy to blame the people who made the mistake. It's very easy to say, well, of course this guy does this, right? He's not a very good developer. They do this all the time. But if you are thinking like a UX designer, what you are thinking about, or like a system thinker, it's really you think, it's not the problem with the people, the problem is with the system. So the question is, what types of errors do we have? What types of bugs do we keep introducing? And how can we prevent them? And there are multiple ways of doing that, but I will give you an example. We do a lot of community events and usually use tic-tac-toe as an example. And the typical design people come up with is this. And it looks quite simple, right? It's move X, move O. That's the kind of thing that you expect. Now the problem is, this is very easy to abuse. You can very easily make a mistake of calling move O, move O, move O. And of course it's not in one function, but imagine you have this spread into multiple functions across the system, and you cannot see like the whole stack. So if you have this, when I point this out, people start throwing exceptions. And if you think about it, this doesn't solve the problem. This just pushes the problem to the runtime, and it tells you, okay, you did something stupid, now try and recover from it. But it doesn't prevent you from actually making the mistake. So can we change the design so that it doesn't happen anymore? And there's a very simple way. Just encapsulate, have one method move, and encapsulate into it the logic of who's the next one to move. And simple things like this, they may not seem much, but I worked with a company that does appliances with the firmware and so on. And they had a lot of bugs. And the problem was, when we looked at past bugs, 80% of them had one root cause. And their root cause was that they were starting much more processes, much more threads than the device could handle. And it was something that was very difficult to debug at runtime. It was very difficult to get there. So, but it had an easy fix. And the fix was to change something in the design so that we make sure you cannot actually start more processes. So things like this, looking at the past bugs, figuring out the root cause and fixing the root cause, changing something in the design to fix the root cause, can help a lot. Now I realize I don't give you recipes. Okay, this is a fairly new way of thinking, and we don't yet have all the recipes we'd like to have. I'd like to have here more examples of how to do mistake proofing in your designs. But I still don't have those because we need to research some more. Okay, satisfaction. We are at a developer conference. We don't talk about really being satisfied of working with the code that we have. We typically are not satisfied with it, especially if it's somebody else's code. But it's still relevant because it's very useful for people to see if there are parts of the code that are very difficult to use, you should probably know about that. That's where mistakes typically tend to happen. And also, people who have more fun, who feel better at work, tend to be more productive. So, I'm just saying, might help. Okay. So we discussed about usability design qualities and kind of looked at each of them in turn and how we can improve for each of them. But there's one more practice that UX designers have been doing, and it's very easy to actually do for code as well. And it's usability testing. Now, what is usability testing in your code? Well, the way we do usability testing is by figuring out a few tasks we need to make, we need to implement. Ask somebody who doesn't know a lot about the product to do it, and then gather feedback. And I will give you an example from our product. I asked my colleague Claudia, who is working on another product than we are, to do a few tasks. And for example, the tasks that were write the code to create a new user, write the code to create a new event, explain how an event is created in the application, and so on. There were 6 different tasks. I forgot to tell her, but she did it anyway. She wasn't allowed to start the application. You just have to look at the code and figure this out. And I timed this to be maximum 15 minutes. So she wasn't allowed to go more than 15 minutes. She should stop after 15 minutes. And we had some very interesting results. I will just go quickly through them. But it pointed out, for example, that creating users, creating event, we have about 3 different ways of doing that in the application. And that's a problem because there's duplication. And then when you change somewhere, you need to change in other places. And it was very easy to find. So it showed an inconsistency in design. There were some tasks that already very quickly, like one, explain how an event is created in the application, took less than 5 minutes. Another one took less than 5 minutes, but she completely missed part of it, the client-side validation, and it was due to a very difficult setup thing. So we had, our product is in Rails, but it uses other libraries that needed to be installed to local Maven. And she didn't know about that, and there was no automation for that. So what we are doing now is to write a Gradle script that will fix this, so that you run one command and you have everything set up. Another one was very quick. And another one was, a very interesting one, was a flow that takes multiple steps, the reset password flow. And after 15 minutes, she couldn't understand the whole flow because it basically got out of the controller and then went back into another controller. And it was very difficult to follow this flow just by looking at the code. So then we started thinking about how to improve that, and it's still work in progress. We have some ideas, but these types of flows are inherently difficult to understand. And it turns out they are difficult to understand for us who are working on that product, as well as for her who wasn't. So, and the usability test ended with some open questions. And it was very interesting to see that she thought the design was very nice, easy to understand. The names and the structure helped a lot to understand the code, but it was very difficult to follow the more complex flow. Now the thing is, every time you take 1 more minute to do something like this, to navigate, to understand existing code, it's 1 minute you are not adding features. So, or it's 1 minute you are not spending on Quora. I don't know what your policy is, but I like to read Quora from time to time. So, again, usability tests can help a lot. And the last one is design elements. Now, design elements is an idea that's new. It doesn't come from UX, it comes from our practice with usable software design. What we did, I had a problem when we started the product because I had a lot of knowledge about software design, but the people who were coming in the team, they had to learn a lot about technology and also about software design. So they couldn't learn everything as quickly as needed. Right, so design elements came from our practice, and what we did was we defined high-level design entities, kind of design patterns, and I'm going to give you just a few examples. So we all know MVC, and one of the main problems with MVC is that if something relates to model, it's very clear where to put it. If something relates to the database, you put it in the model. If something relates to the view, obviously with the UI, you put it in the view. But what do you do with the other things? They go into controller, right? That's a very common pattern I see. So what we did instead was to define not only what each of these types of entities is doing, but also who is collaborating with and how do we test it. So for example, there are things like the controller who delegates the operations, render the correct view template and error, and we test it using a specific type of functional test which only test one page. Command objects which only validate operations, collaborate with other things and are tested using unit tests, and so on. There are more here, but I will skip them because we are very close to the end of the session. And these design elements helped us. Well, the idea was to get some things that are consistent throughout the application, and it's very easy to find them, it's very easy to understand what they do. And they are about 90% of our code, and they help us a lot due to the consistency. Now, if you are curious about this, I can show you code. So, conclusions. What to tell managers? Okay, if you want to do this. Each usability has economical benefits. It has benefits for the user, and it has benefits for the application developers. And it's the same here. It's faster to integrate new developers in the team if you optimize learnability. It's faster to implement typical tasks due to efficiency. You do less mistakes, you work less on mistakes if you optimize for mistake proofing, and you have more motivation if you like the design. So any manager will respond to 2 out of these 5. They don't have to respond to all 5, but probably to 2 is okay. So my belief is that you deserve better, and there are a few ways of doing this, and we are a community and we can gather around and try to do more for each other and try to do more for our teammates, because this will come back to us and we'll feel much better when developing. If you want to contact me, tell me about your experiences. These are my, this is where you can find me. You can also find me later today at the conference. Don't be afraid to come to me, ask me questions, show me code, pair with me if you want to. So, and you have a special price for the usable software design book for the price of kind of 2 Turkish pizzas. If you go at this link, you can buy it today. And I hope you will enjoy this. Thank you very much. It's been a pleasure for me to be here.